fun stuff of rational expressions. Now, these always had a bunch of different rules built to them. For example, the first thing that we looked at when we dealt with rationals was that we would get the x-intercepts were from the zeros of the numerator. We got the x-intercepts out of the zeros of the numerator. Excuse me. The next thing that you were always able to get was that you got the vertical asymptotes. The vertical asymptotes came from the zeros of the denominator.
Wait, is this for this one?
Yeah, it's just been a while since we talked about it.
Right.
Just trying to refresh you. What's that? That's smart. It's helpful. So you have vertical asymptotes for zeros of the denominator. X-intercepts were always zeros of the numerator. And then you had three different possible ways of figuring out horizontal asymptotes. And those were always dependent upon degrees. So your horizontal asymptotes depended on degree numerator, degree denominator. Remember, we used m and n for that. So you had three cases. Top was greater, bottom was greater, or they were equal. And in one of those cases, it not only didn't create a horizontal asymptote, it created a slant asymptote. And I'll walk you through an example of that again, a nice, easy way to find
Which
those.
one's the same?
When you have slant, and I'll talk about that in a second. All right, let's take care of the horizontals first. Now, if the numerator has a greater degree than the denominator, was there a horizontal asymptote? No, correct. So there's no asymptote here. If it was greater than in the denominator, it was always located where? At 0, good. And then if they were equal, what did you do? Yeah, it was the coefficients. Excuse me. It was at y equals a over b, where a and b are lead coefficients. Okay? And that's how you were able to find all of your asymptotes. The extra step that I threw at you guys then was the whole idea of that slant asymptote. Now, the slant asymptote occurred. Can I slide this up? I don't know how far you guys are on that.
You're good.
Thanks. I try to be. It's bad, I know. Your slant asymptote would occur when m degree plus 1 from n degree. Okay?
Wait, so like if m was 2x and n was 2x squared, then that would be it?
Other way around. If it was an x squared over an x.
Can you give an example real quick?
No, absolutely not. No, it's something different, and you'll learn that. You'll do stuff like that in pre-calc. I'm going right at the slant asymptote case with you guys. I figure that's enough. Just that little extra push for this time around. Remember, when you're working with your slant asymptotes, will occur when the degree of the numerator is 1 greater than the degree of the denominator. if it's 5th degree, 4th degree, 7th degree, 6th degree, 27th degree, 26th degree, or squared over x. Every single one of them works. Did it sound like a dog barking?
Yeah.
I mean, I know my cough sounds pretty bad sometimes too, but that was.
We should.
Yes, and I'm getting there. And remember, when you're doing slant asymptotes, and I think it's number 25 on here that has it. Yeah, look at number 25 real fast, guys. I'm going to walk you through again how you find it. So on number 25, this is just like Megan was saying, we use long division to get our linear term for the slant asymptote. So remember, when you're using long division, you're trying to turn the first parts of the functions into ones, okay, or into the same value. So how do you turn a negative 4x into a positive 1x squared? Yes.
Negative 1/4 x.
Yeah, negative 1/4 x. So and this is where some of the mental stuff you have to work with. It's negative 1/4 x. Now, even though you're going to get some crummy fractions from time to time, you're going to notice that the fractions are going to become friendly. They're not generally going to be awful where you have to worry about really nasty values. Usually they work pretty clean, okay? So if I distribute this through, I have a negative times a negative, positive. 1/4 times a 4 is 1, x times x is x squared. Right? And I do the same thing with the 4. And now it becomes minus, excuse me, minus the x. Okay? Everybody all right with that? Now you remember, you're subtracting each of these. So x squared minus x squared is gone. We've eliminated it. And then I have to do 5 minus negative 1, otherwise known as 6. So now how do you turn a negative 4 into a 6? And that's fine if you want to simplify the fraction, go for it. But for us mere mortals, I don't know how to do that. But if I do this, negative 6 over 4, wouldn't that be okay? All you're doing is you're trying to take a negative 4 times what equals 6 divided by negative 4. And there's your answer. That's all you have to do to figure those out, even if they are crappy fractions. Yes, ma'am?
Do you need the remainder?
No, you don't. And that's the thing. Because once you know that you've eliminated this value, now we have what, a negative, so we have a 6x, and then I honestly don't even care what that last value is, because this is going to go away. When I subtract it, I'm going to get a 0, which means that this here is my linear portion. It's my y equals mx plus b. It's my slope-intercept form. So the equation of the slant asymptote here would be y equals negative 1/4 x minus 3x. And Hopworth, this is where I would simplify it. You want to write it as negative 3/2 right off the bat? Fine, no problem. But in my mind, I like to see why it's distributed and working through. Yeah.
Are we getting our calculators on test?
I don't think so, because you don't need them. If I have you graph and plot points, believe me, everything works rather cleanly. Yeah.
If the test tomorrow.
Yes.
I will not be here tomorrow.
Oh no. You get the hard version on Wednesday. Sweet. Maybe. Maybe not. What?
So when you find like the extra points, are you just taking like what you get for the extra stuff?
Usually, a lot of times, the easiest way to find values and stuff
Yeah.
is if you've got asymptote here, I pick a couple numbers on both sides here, a couple numbers on both sides here, and just start playing with it.
That's why I always feel like I know what I'm doing, and then the graphs always look like totally messed up.
And I try to make sure that when you graph stuff, the ones that I pick for tests, that they become real quick about how to figure it out.
Oh, wait.
Because you're right, it can be rather painstaking. And that's why I don't let you use the calculator. Hold up, guys, hold up.
We like turn it the wrong way, so I know sometimes I'll find the 2 points and then I'll go
Yeah.
like down instead of up. If we do that, will that?
It's, I mean, I do my best to make sure that it becomes kind of, whether or not, you know how sometimes you can get a point here and a point here? If they're, I try, that way you're gonna see, oh, it's gotta do that. I try to make sure that I pick ones that are pretty obvious, okay? If your points are labeled correctly and all that, I don't think it's that big of a deal. Because honestly, when you do this stuff again later on, what are you gonna have with you? But I can still have you list everything out that you don't need a calculator for. What else we got? Does that help on these?
On the domain, which is.
Oh yeah, thank you for asking. On this problem here, I forgot what it was to start with. This was, the numerator was the numerator for this one was the x squared plus 5x plus 4, negative 4x plus 4. So my x-intercept for this one would have been at negative 4, negative 1. My asymptotes would have been at 1/4. So in this case here, my domain, because it's just one asymptote, my domain would be all values of x except x equaling 1/4. So my domain here would be x not equal to 1/4.
So you just go off of like A and B, or.
What do you mean? I'm not worried about A and B.
Wait, so how do you get the 1/4?
What's the zero of the denominator?
Oh, yeah. Okay.
Oh, it's not 1/4, it's 1, I'm sorry. I'm stuck on the fourth part here, sorry.
Oh, okay.
Yeah, so what makes the denominator 0? 1. What can't your domain be? X can't be 1. That's all, okay? The range of this one will be all real because since there's a slant asymptote, that means there's no horizontal asymptote. So the same deal that if you have your range is always going to be everything except whatever your horizontal asymptote is placed at. And in the cases, it's either going to be at 0 or it's going to be at the coefficients that they are removing.
So like in the last question, like number 8, when we talked about like if it's like 2 minus 2 and plus 2, it's like let's say an example of the domain is it can't be negative 2 and it can't be positive 2 because
Right.
it's 0 and 1.
Right. That's all it is. It's your domain's always, it's all real numbers except where it's restricted. And the restrictions for a lot of these are at the asymptotes. Okay. And when we get to exponential growth and decay, you'll start to see there's a pattern that evolves about the A, H, and K's about where domain and ranges keep firing from within those as well. What else you got? What? Are you two plotting?
Yes.
Why? That's true. Yeah, George's been really quiet. All right, you ready to go, or you just had a nervous twitch about an eraser? Now, if it's an eraser, would it be dense and you're not going to be able to hear anything? Would you prefer to have a scissor to cut that open?
I've been working on one.
Grab Artie, you're such a jerk.
She always.
Artie, you're so irresponsible.
She always gets.
No, excuse alert, excuse alert,
So yeah.
excuse alert, excuse alert. All right, so ladies and gentlemen, there's been a couple other questions that come up on this one from earlier today when we were working. I'll just kind of cut to them here. One of the things that I want you to see there that happens like on basically right off the bat on number 1.
Can we just cross multiply with that one?
Is that an equal sign?
No, it's not.
No. Now, is everybody okay if I use X's?
Yeah.
one of the things that,
Can you just do P's?
what's that? The computer software just generates variables. It drives me nuts. Anyway, so in order to do this simplification, you have to have common denominator. Well, when you take common denominators, you have to factor what you have first. So you need to factor the secondary term to see what your common would be, which means your overall common denominator would be 3 times x plus 2 times 3x minus 5. Those are the terms that are there. Remember, we don't multiply out denominators. It's a waste of time. But we go through the numerator. So the numerator, you're going to have fraction on the left needs both of these parts, so it'll be a 6x times 3x plus 6. And all I did there is just put it back to the way it was in the unfactored version. Excuse me. Fraction on the right, 6 needs the 3x minus 5. So now you go ahead and simplify stuff out. You're going to get a 18x squared plus a 36x plus an 18x minus a 30. And I just rewrote it one more time before I put in the denominator again. And I have that. What can you do to the numerator? Take out something bigger.
6.
Which is it?
6.
6. In the numerator, they're all divisible by 6. So factor out a 6, and you have 6 times the quantity, 3x squared, 9x minus 5. And this little trick will happen from time to time where you get, only thing that'll be able to simplify out is going to be some integer value. And one of the reasons this happened is because if you look back at the problem, you had in the denominator to start with, we had 3's on both sides. So we had a 3x and we had another 3x. So as you multiply these things through, you're going to get an extra part of it. So your final answer then would have been just, excuse me, I simplify this out, this becomes a 2. And I've been saying all along to distribute out and combine in your numerators. So I would write this as a final answer as 6x squared plus 18x minus 10 all over x plus 2x and 3x minus 5. Okay? And just leave it like that. A lot of people make this first problem way harder than it needs to be. Way harder than it needs to be. What's it? Look over at 20 real quick. I've had this one come up a couple times throughout the day today as well.
Oh, you just have to break apart the middle, right? Yeah,
Now, all I did there is I just wrote the problem down and I factored everything that I could first, because that's the easiest way to do things. Now I need to get rid of my fractions. What are you going to multiply everything by to have them drop?
X minus 2, X minus 4.
Yeah. Multiply everything by the x minus 2, x minus 4. And then just go fraction by fraction. The first one has a minus x minus 4. It needs the x plus 2, or excuse me, x minus 2. So one in the middle has everything. One on the end needs the plus, or it needs the minus 4. Yeah, and then you just go from there. There's a lot of foiling and a lot of factoring and back and forth. It is. We do put the fun in functions.
We definitely need them to
Well, Well, is it better to do that or we put the FU in functions?
I mean, that's what it feels like right now, so.
I'd go with the
Not even a smirk out of that one?
You lost your touch.
You never have it.
I never No, but Luca usually forgets about stuff.
It just reminds me, we put the Spring in Springfield song from The Simpsons. And now, Jaden, this is back to the part where you were asking earlier, can I cross out the x squareds?
Yes,
Because you
please.
eliminate them through, because they're not terms, they're just, it's all through addition and all that now. So the x squareds drop. 3x minus 10, bring that over, we wind up with an x. So this becomes 0 here, and this is a 10. So we have 2x minus 6, x is 3. And does 3 work? Is it restricted?
No, it's not.
It's not restricted on 3, okay. Screw it. And it's just a matter of just double checking. And quite honestly, a lot of these you can check, you can probably check them through in your head. They're not really large. Not like it's 8/5.
So basically, like as far as you go through, you just need to make sure that like the denominator doesn't get eliminated.
Yeah, pretty much. And really, what you guys are going to screw up, and this is pretty obvious, pretty honest with you, is you're going to go too fast and you're going to write something down incorrectly. You'll miss a sign. Yeah, you're going to miss a sign as you're writing something down. You'll make it a minus instead of a plus. You'll make it. You'll think it's a 2, but it's a 5. You know, it's something like, and then you're going to get some crazy answer and not know what. And that's what happened last night. You're like, oh. And it's something stupid like that happens. So just slow yourselves down. I think there's only there's not very many parts to this. This is pretty quick. There's a couple good ones. I saved a couple that I haven't shown you yet, but it's good for you.
We're gonna dump calculator, right?
I'll let you have a dump calculator, yes. So, but I'll give you guys some of those. I'll have plenty of those tomorrow. Hey, just so you guys. Oh wait. No, it won't matter to you guys because this is after flex. Second hour, I might be a minute or like a second. I'll be running up here from the auditorium. You guys remember last year when you did the clinometer stuff in the auditorium looking at the
That was
angles?
so much fun, honestly.
Yeah, we're doing that tomorrow. That's our day tomorrow. So
Can we go on a field trip?
you're taking a test. So
I think our test is the next day.
no. We're gonna do exponential growth. We have exponential growth, exponential decay, growth and decay word problems. Appreciation, depreciation, account balances and stuff like that. It's a lot of fun. Yes, ma'am. Guys, I can't hear.
Yeah.